Hello and welcome to this session. This session is on Numpy, which stands for numerical Python. So Numpy is nothing but a powerful library there in Python, which is very fast and versatile. At the same point of time, Numpy offers comprehensive mathematical functions for random number generations, linear algebra routines, and so on. And it is very much helpful while you are doing your computations here in Python. Now, while will be working with NumPy, we will be using Google Colab. So if you type, as you can see here in the screen, we have typed Google Colab, right? So similarly, you can type Google Colab on your screen and it will be there in front of you. As you can see here, once you type it and hit the search button, so these are the search results which you have in front of you, and then just click on Google Colab. Once you do that, you will be redirected to the Google Collaboratory. So once you are here in the Google Collaboratory, what you can do, you can go for a new notebook. The new notebook will open in front of you in a while. So once the new notebook is there in front of you, you can have the different kind of programs or codes written in the notebook for you. So as you can see here, this one is a NumPy tutorial. So you can have two different types of cells. One is code, another is text. If you are looking for text, that is, if you want to give some kind of a heading for certain kinds of programming that you are willing to do, then you can do it in a text cell. For example, I am providing here a heading which is NumPy tutorial, right? Now, if I select it, the entire thing and hit the bold button, then it will be looking like this. Okay. Now hit the code one. So once you hit the code, a code cell will open in front of you. Now let's see how we can use NumPy. To use NumPy, the basic thing which we require is that a Python interface, right? That we are having right now in Google Colab in front of us. Now, before we proceed, we can also save it with a name, right? So the entire operations that we will be doing, the entire file that will be generating. So here we can save it as NumPy tutorial, right? So this NumPy tutorial is saved in front of you. So what we can do as of now is we can type or import. What we have to import? We have to import here the NumPy library. How we will be importing the NumPy library? It is very simple. We will be typing the NumPy library here as import NumPy as NP. So import NumPy as NP. While I am typing, I will be expecting all of you to type along with me so that you can practice as well as you can also get acquainted with this. So once I type import NumPy as NP, so I can also write a comment here like importing NumPy. Okay. So as I have told earlier also, you need to hit this run button so that the cells gets acquainted that what is being actually done in the cell. So once you are doing this, import NumPy as NP. So now it is being executed in this particular cell. Once it is executed, meanwhile, you can also hit and have the next cell for coding. Now I will try to show you a NumPy array. A NumPy array is nothing but we can combine different, let's say, numbers at one place. How? Let's say we declare array as AR. So if we are declaring array as AR, then equals to NP. Why NP? Because we have imported numpy as NP here, because every time writing numpy, which is big, it may cause typing error. It is a big word and things like that. So we can have a short version of it, which is numpy as NP. So NP dot array, you can type like this, and you can have any numbers, right? So what are the numbers you can have? This is a one-dimensional array. 4, comma 5, comma 7, comma 9. Let's say these are the different kinds of numbers you are having. Okay. So this is what create a 1D array in NumPy. So let's see how it looks like. Okay. So if I hit the run button now, it will be created in front of you and you will see that how it looks like. So to see what has been created, you have to print it. Okay. So if you are printing it, what will happen? You will see this one-dimensional array is created in front of you. Now, if you do not print it, what will happen? Let's see. If you do not print it, then also you will get the data type along with the array, right? So this is an array and the elements are this. Okay. So this is how you create a one-dimensional array in NumPy. After this, you can have a two-dimensional array as well. So I'm naming it as AR underscore 2D, which is two-dimensional. Now, np.array just similar like the earlier one, but then here it is two-dimensional, right? So that is why we have to do this. That is, we have to make it two-dimensional. So first I have given this opening brace, then one square bracket, then second square bracket. Then after that, if I am writing the elements here, let's say 11, 12, 14, and then 16. So this is representing one particular row. So since this is two-dimensional, then what we need to do? We need to again have another one, right? So for another one, open one more brace like this, square brace, and then you can have certain numbers like 22, 24, 21, and 15, let's say. Now, once this is done, you can again write like this, ARR underscore 2D. All right. Once you are writing like this and hitting run here, you are supposed to get a two-dimensional array, right? But then here there is a spelling mistake. I have written AR underscore 2D, but here ARR. So ARR is not able to recognize. The cell is not recognizing it because it has been declared as AR underscore 2D. So you omit this and then again rerun it. Once you rerun it, you will get a two-dimensional array, right? So you have to be very careful that whatever you are declaring in the print also, you have to write the same thing, okay? So this is how you create a two-dimensional array with NumPy. I think, and I also expect that you are typing along with me so that you are able to practice this, right? Now, if I would like to test that, what is the dimension of the array? Fine. So if I hit run here, I will get 2 cross 4. So this is 2 rows and 4 columns. So 2 rows and 1, 2, 3, 4. Okay. So again, if I want to test that what is the data type of the array, then also I can have the data type of the array as AR underscore 2D dot D type. Okay. So let's see. Again, there is a spelling mistake. I'm sorry. So here, if I hit run, so I will get AR underscore. So data type int64. Okay. So here, what you get is that the type of array is int64. Then, proceeding further, if I now would like to do certain kinds of multiplication. Earlier in list, you have seen that if you would like to multiply the list and all the elements of the list by a certain number, then what you have to do, you have to run a for loop so that it iterates throughout the entire list and then you can do the multiplication. So this is not required once you are using this numpy. So numpy arrays like this. So here, if I write like this, print, okay, AR. What is AR? AR is the first one-dimensional array which I have printed here. Okay, AR cross or multiplied by 2. Okay, then once I hit run, I will get the multiplication at one go. You see, what are the elements there in here? 4, 5, 7, and 9, and multiplied by 2, it has been 4 cross 2, 8, 5 cross 2, 10, 7 cross 2, 14, and 9 cross 2, 18, right? So just by multiplying it, you will get it at one go. You need not have to run any loop or anything, right? Similarly, you can do it for the two-dimensional array, okay? So here, if you multiply this two-dimensional array with 2 or 4, whatever you feel like, and hit the run button here, so you will get one the multiplication of the entire thing. So as you can see here, the entire thing AR underscore 2D is being multiplied by 4 and you get the results, right, in the form of multiplied values. Okay. So in this way, you can multiply without any kind of hassle. So hassle-free multiplication. Okay. So here, this is multiply 1D, one dimensional. Here it is multiply 2D, that is two dimensional. Okay. Now after this, what can I show you? I can show you one more thing, that is we are having two cells now. So in this cell, I would like to show you what I will show you. I will show you certain kinds of mathematical operations. So let's say mathematical operations with numpy. So what is this mathematical operation with numpy? The different kinds of addition, subtraction, and things like that. Let's say I am declaring one array. So let's say this is the array 1. So once I declare that this is array 1 and declare the array for this. So while you are declaring an NP array, that is numpy array, you can do it like this, np dot array. Okay. So here when you have declared the array, as you can see here, you have also done the same thing, np.array. So similarly, you will be declaring here as np.array. So let us declare a one-dimensional array. Okay. So what can be that? That can be, let's say 6, 7, 8, 9. And once you do this, after that, let's declare the second array so that we can have different functionalities of arrays explained in front of you. So what can be the second array? Let it be 3, 2, 4, 1. Okay. Now, if I would like to do certain mathematical operations on this, so I can print AR underscore 1 plus AR underscore 2. Okay. So let's see what is the response. In this, I will get a response. As you can see, clearly it is added, right? So this is what is your nothing but addition. Okay. I just change the sign here and make it a subtraction. Okay. And also change the comment here. So this is subtract. Sorry. Subtract. Okay. So once I do the subtraction, what I will get? 3548. Okay. After this, what I can do? I can do multiplication. So for multiplication, what I need to write is np dot multiply. So you can see that if I write this np dot multiply and under this I have to provide the values. So what are the values? The values, as we already have, are ar underscore 1 comma ar underscore 2. So once I provide these two values, and hit the run button here. So what I will get? I will get the multiplication, right? Similarly, so this can be changed to multiply now. Okay, multiply. So this is the result for multiplication. Now after this, if I would like to divide, okay, so let's see the divisions, how the division is being done. The same way, just change it to divide, and also the comment I would like to change to divide because it signifies what operation is being done here for the reader. So as you can see, this is the perfect division which has been done. Okay. Finally, if I would like to do the square root of any one of these, so nothing to do, you just write sqrt and then write one argument in between, that is any one array, so that all the elements in that array can be done for, or can be operated for the square root function. So here is the square root function for you, and once I hit the run button, what I will get? I will get the square root of the different values. Okay, so this is how you will also get the square root. Now if I would like to get the dot product, okay, so for these two, if I would like to get the dot product, what I will do? I will just write dot, okay, here underscore 1, comma, after that what I need to write? I think you have rightly guessed, here underscore 2. Okay, so once I do this, what I will get? These are the product of two 1D, one dimensional matrices. So it can also be two dimensional matrices, and you can have the product like this. So here the product will be 6 cross 3 18, 7 cross 2 14, 8 cross 4 32, 9 cross 1 1. So adding all this product, it will give you 73. So this is how the dot product is being done. So once this is done, and you get the value, you can also have transpose of a matrix. How you can do that? Let's say a matrix be denoted by M, and let's say let us declare a matrix. So a matrix will be declared usually by a two-dimensional array by which we would like to take the transpose. So here we are already having a two-dimensional matrix. Why don't we copy this and paste it here? Okay, we have copied it and we have pasted it here. Fine. So np.array, as you can see, it is being repeated here. Why? Because of the fact I have already typed this at the beginning. So that is why it is repeated here. And np.array, let's say, let it be like this. So now if I would like to see what is the matrix, print m, okay, it must provide me with the matrix. So here is the matrix for me. So once the matrix is given for me, if I would like to take the transpose of this particular matrix, what I need to type? I need to type print, okay, then np. Every time, since this is a numpy function, numpy mathematical function, and it is been imported as np, you need to type this np and then transpose. After transpose, you provide the name of the matrix, and you see that the matrix will be transposed for you here. So as you can see that this entire matrix, a transpose is given for the matrix. So as you see this, you will understand that how easily these functions can be carried out once you are having this numpy function, right? So then when you have done this, after that you can also declare that arrays of zeros, arrays of ones, different numbers, right? What is that? I'm showing it to you. So let's say n, if you write n equals to np dot zeros like this, and then if you write np dot zeros, let's say 4 comma 4, then what will happen? Let's see. So np dot 0 4 comma 4 will provide you with a matrix again of zeros, right? So this is, here you are getting unexpected EOF while parsing. Why? Because here we have not closed this bracket. So that is why this thing is happening. And now we are having the 0. Let's see here, and we will be having the 0, right? So here you can see the array of 0. If you just replace it with print n, then what you will get? You will get this. Okay, all zeros. So if you now would like to have ones, you can also have that. How? Let's see. So this is how you can get ones. Okay. So randomly you can generate. Now, if I say randomly, then how will you generate random numbers? Okay. Random dot random. Fine. So if you are doing this, you are generated with random numbers here. Okay. So you may be wondering what will happen if you write like this. Okay. So it is giving you an error. So please remember that you have to write like this, random dot random, because from the module random, the random function is being called so that you can generate the random numbers like this. Okay. Now you can also create an identity matrix. Let's say, how will you create? Let's say the identity matrix Bi equals to what you can write, np dot I, that is numpy dot I. Let's say you write 2. So you are supposed to get a 2 cross 2 matrix. So what will happen? Once you hit the run and write print I, it will be there printed in front of you. So as you can see, an identity matrix has been created in front of you. Okay. So these are the several functions you can have with the help of the NumPy array.